Greetings! Here we have a Votrax Type and Talk text-to-speech synthesizer. I recently got this from my buddy JJ, and thanks for giving me the usual student discount. And it came just like this. Well, it was actually in a box, but it had been taken apart by JJ, and he said it kind of worked, but sometimes it worked and sometimes he got gibberish out of it. So he took it apart and replaced all of the caps. It didn't change anything, so he put it back in the box, and that's how I ended up with it. It did come with this note that the Votrax may need just reassembled and tested. Well, let's find out. So if we look at the pieces we got a PCB over here with everything on it, and a potted module hiding the secrets, the deep down secrets of this device, even though the actual phonetic synthesizer is out in the open. It's an SC-01A, and if you've ever seen, or I should say heard, a Qbert arcade game, this is what they use in that arcade game to create speech. We have a bunch of knobs and hardware, the rear panel, the main case, the side panels, the aforementioned caps that were replaced with new caps. I did test these and they seemed okay. A little bit out of spec, but I guess new caps can't hurt, at least not too much. And it came with the branded power supply, even though that looked really familiar to me. And have a look at this. We have a Radio Shack supply over here. It's got the same case, different writing on top, but I think that's just the plastic piece they stuck on. Same connectors, AC and a 5-pin DIN, and that's about it. I'm sure this was made by the same manufacturer, even though this was custom made for Radio Shack, and this was made by Tam Radio. So yeah, that kind of sums up the parts that I got, and I think we should have a look at the PCB. So for a quick tour of the PCB, what we have here, not necessarily in the order of importance, but power switch. We have a 5-pin DIN receptacle for the power supply, a DB25 for an RS-232 connection. This was supposed to be a universal speech synthesizer that you could hook up to anything that had an RS-232C port. Next, we have a dip switch that selects baud rates, which range from 9600 baud down to, I think, either 300 or 110 baud. An audio output, assorted chips, regulator, crystal, 6850, which is the UART used to talk to this port, the SC01 itself, of course, and from the looks of it, nothing real interesting on here. And that's probably all inside this potted module. I really wanted to know what's in the potted part, but before reinventing the wheel, I actually did some research. And a fellow by the name of Kevin Horton put up a blog page in which he took one of these guys and unpotted this part. Unpotted, depotted, made the pot disappear, whatever. I have done so myself many years ago, and it's messy at best. Kevin talked about chemicals that could be used to do this, but he ended up using a heat gun and carefully chipping off the potting material. And what you're looking at is the result he got, which is the entire board, but also, of course, includes what's potted. I apologize for the quality of this schematic, but beggars can't be choosers. So if we look at this, let's see. We have the SCO1 over here, just fed through some data lines. And it also, note, it has a pot on this pin which changes the clock frequency of it, so you can manually inflect the speech. On Qbert, the speech inflection was actually under computer control and made it sound that much more natural, for lack of a better term. But getting back to this guy, I mean, we have our power supply here, but it turns out that in the potted area, we have a 6802, and I think this is the EEPROM. No, this has a reset. What is this? Oh no, this is the dip switch. And then we have an EEPROM here and two 2114s. No, those are actually outside. The salient parts inside the pot, the potted area, are that it uses a 6802, and the magic is in a 4K ROM over here, which is in there. That does the text-to-speech conversion. And yes, I mean, the code was written in assembly, but 4K is not a whole lot to do a text-to-speech synthesizer. But we'll find out later how successful the manufacturer was with this. But now we know what's in there, and we can build one of these. The only thing that's going to be somewhat expensive is the SCO1 speech chip, which you can still get, but it's not cheap, and it's something you should be extremely careful with when prototyping. Well, here's a test setup I'm using. I will try to explain what's going on here. This needs a true RS-232C connection. And what's coming out, the way I achieve that is I got a laptop set up. And some of you may have seen some of my previous videos where I had to drive some Heathkit equipment. And the first thing in line is, let me unplug this. It's basically this is the USB to RS-232 interface. It's based on an Arduino Uno R3, which is this board, but you'll notice that there is no processor in here. And the reason for that is all I need is the USB to RS-232 converter that's built into the board over here. And then what I do is I tap into the the transmit and receive lines, which are available in this on the expansion connectors. But that's not enough. Remember I said that the original owner had problems with reliability on it, and I think one of his problems was that he just used the 5-volt part of the converter, of whatever converter he used, and went straight into the Votrax with that. What this has on it additionally is a line driver and level shifter over here, and what that does is it takes the transmitted signals coming out of the computer and bumps them from 0 to 5, from 0 to 5 to 0 to 12, and the incoming stuff coming from the Votrax is level shifted from 0 to 12 volts to 0 to 5 volts, so nothing gets smoked. So this gives us the interface, and once I put this in, things didn't still work. Well, it looked like I was stuck, so I did the unthinkable, and I read the manual. And reading the manual revealed that if you want to hook up the Votrax to a computer, you need to take the CTS, DCD, and DTR signals from the Votrax. This cable plugs into the back over here, and tie them together. So that's what I did. Well, before that, of course, I have the actual serial cable here, but I have a little adapter plug I made that is supposed to plug directly into the Arduino board, but that only had receive and transmit on it on my original one, so I had to make a new one, bring out the 3 signals I just referred to, and using this board here, I just shorted those 3 signals together as instructed to in the manual, and then just pass through the receive and transmit. So let's give her a whirl. I originally used putty on the PC, which is, but it also seemed to be a part of my problems not getting things to work properly. So what I did was I just threw together a wrapper around the Windows serial port in C#, and so I have some control over what gets transmitted and be able to monitor things that are coming back. And with that done, things seem to work. So we're obviously going to need an amplifier. And now if I turn on the Votrax,
system ready.
In case you didn't understand that, it does say system ready, which seems to indicate that it's okay and it likes the connection. But if I run this thing, it's again, it's just a wrapper around the serial port. You can type in things and have the Votrax say it. And it promptly bombed on me because I didn't have the serial port plugged in. Yeah. Okay, let's see. Okay, work.
Greetings.
So there you go. It basically sends out whatever I type in here, and then it sends back to me what it received, terminated by a carriage return. So at this point we can type in stuff. I was going to make this into a fancy all-inclusive program, but I gave up after a while. I just threw in a combo box and put some things in so I don't have to type them in. But hearing some words.
Professor. Welcome.
So no peeking at the screen. You're just supposed to listen and see if you understand what this thing is saying.
Bye bye.
That one was clear.
Artifact electronics. Radio Shack Model 1. Floor games.
So I mentioned that this was used in the Qbert video game. However, in the Qbert video game, even though it's using the SCO1 chip, they also implemented inflection control on it, control through the computer. So even though Qbert doesn't say a whole lot, when it does say something that makes sense, it does inflect it, and it does sound better than this. Now we have two controls on this, and if we look at them on the front panel, the two buttons we have, or the two knobs here, one of course is labeled volume, and that should be pretty obvious.
Radio Shack Model 1.
And that just drives the output. But the next one says frequency. And that's actually the inflection control used on this. So you have to do it in real time. And that's not very convenient, but...
Radio Shack Model 1. Radio Shack Model 1.
So if you're real good at twirling the right side knob, come on.
Radio Shack Model 1.
So the fastest is this,
Radio Shack Model 1.
and the slowest is this. If I can get it to click. Let's try that again.
Radio Shack Model 1.
So it would be really cool if you could send commands over from the computer, embed them into your text that would change inflection too, and make it sound even more natural than it sounds now. One of the downsides is that the way I'm set up, I can't really detect when the Votrax is done saying something. So if I wanted to have it output a more lengthy blob of text, I'd have to kind of guess how long each word takes, put delays in there, and that would probably throw the balance of what a sentence sounds like overboard. Now, I could probably figure out how to know when the input buffer is emptied here. The input buffer basically just takes all of the ASCII characters, converts them to phonemes, and sends them to the speech chip. And I didn't mention this, but it is a text-to-speech converter, but you can bypass that part of it. And there's a phoneme list in the manual where you can directly send over phonemes if the text-to-speech is not doing what you want it to do. Now, one way to solve the problem of monitoring, whether this is still busy or not, would probably be for me to monitor the RS-232 control signals that are coming out of the Votrax. The problem is I would obviously have to expand this to be able to read the state of the signals, or one of the signals. Probably the the DCD signal, and when that changes from high to low, then that would tell me that the buffer in here is empty, and I can send out the next word to it. The other interesting application they talk about is that this could be hooked up directly to a modem. So if somebody's talking to you, or is sending text to you, you can pipe the text straight into this and it'll say whatever is coming out of the modem. I don't think I'll be trying that, but I think that would have, back in the day, that would have been a real cool thing to do if your friend called you and whatever, kind of like text-to-speech email, whatever they typed, you would hear on your end. And if they had a Votrax, you could probably do the same, except that when this is hooked up to the modem, you can't hook it up to a computer. So, as you can see, it would probably be a more involved project to get that to work bidirectionally. But the possibilities are endless. Thanks for watching. Leave me a comment if you have any suggestions, or just leave me a comment because you want to talk. And we will see you the next time.